Hey Zach, this is Mr. Caslin. Today I want to look at a rational equation. This one's got a couple things you want to watch out for, so I thought I'd work this one specifically. It's a rational equation. It's not a fraction equal to a fraction. What we have is a fraction plus a fraction is equal to a fraction. That means we're not allowed to cross multiply, so we're going to multiply everything by the common denominator. Now, we have a little pattern here that we saw last time that can be tricky. We have a 3 minus x and an x minus 3. Those are not the same. Okay, subtraction is not commutative. What that means is, remember your properties. If you had an x plus 3 and a 3 plus x, those are considered to be commutative because you could change the order, just change the order and those are equal. Okay, subtraction is not commutative. You can't. X minus 3 is not the same as 3 minus x. To prove that to you, that'd be like saying 3 minus 1 is equal to 1 minus 3. Well, this one's equal to 2, this one's equal to negative 2. Okay, so they're not the same. All right, so what you want to do though when you see this pattern is change the order. You had negative x plus 3. Okay, by changing the order, it's still not the same as x minus 3. But watch what happens when, let's get rid of this negative. Okay, let's factor out a negative 1. Okay, factoring it out is the same as dividing. Negative x divided by negative 1 is x, and 3 divided by negative 1 is negative 3. Okay, so all of a sudden this x minus 3, you have an x minus 3. You have this leftover negative 1. You could call your common denominator negative 1 times x minus 3, also known as negative x times x minus 3. That could be a common denominator. What you could also do is, let's look up here in the numerator. We could factor out a negative 1 up here and get negative x, excuse me, not negative x. Of course, that would be a positive x minus 1. Down here in the, we're replacing this down in the denominator, we said we had negative 1 x minus 3. Okay, notice the numerator and denominator now have this common factor of negative 1. Negative 1 divided by negative 1 is 1, so that's why we can just cancel these out. Alright, so let's summarize here. What we've ended up with is 2 divided by x minus 3 plus 1 over x is equal to, now over here we have x minus 1 over x minus 3. So to recap, we took this 3 minus x, changed the order, factor out a negative 1, and you can get this term here to match this term here. Okay, so now we're ready to multiply through by our common denominator. X minus 3, remember, is prime, so we're just going to multiply that by the other denominator. We have x times x minus 3. That's our LCD. If you want to think of that as a fraction, it is. Now, the other thing you have to watch out for, remember your teacher talks about domain restrictions. Okay, what numbers make denominator 0? Let's be careful. Let's remember that in this problem x cannot be equal to 3. Okay, so before you start working with all of this, see if there's any other domain restrictions. Oh, by the way, x cannot be equal to 0. Make this denominator 0. And over here, 3 minus x, x cannot be equal to 3, which we already have. Okay, so watch out for this. We'll have to check our answers against these restrictions. Okay, so moving along. Now we're ready to do our multiplication. Now, the purpose of multiplying by the common denominator is to get rid of these fractions. So hopefully when we're done here in the next line, we don't have any fractions left. X minus 3 divided by x minus 3 is 1, so think of those as canceling. Then you're left with 2x. This part you're good at. So we'll just cruise through this. X divided by x, those cancel. So you're left with x minus 3. And x minus 3 divided by x minus 3. You're left with x times x minus 1. Now, I could have distributed that in my head, but I think to avoid some small mistakes, let's just write x times, remember these cancel. You're left with x times x minus 1. Okay, so let's not try to do too many steps all in once. Okay, we accomplished our mission. We got rid of our fractions. Now we have an algebra equation to solve. Now let's distribute that x. You're going to get an x squared minus x. All right, this x squared here is telling me, well, guess what? We have a quadratic. Okay, we're going to end up probably factoring or using quadratic formula. I like my x squared to be positive, so we're going to leave this x squared on this side. Okay. Now over here we're going to end up with 3x, right? Okay, so when you subtract 3x from both sides, you get negative x minus 3x, which is negative 4x. So we subtract 3x, and then we're going to get rid of this negative 3, we have to add 3. Okay, so we've ended up setting our quadratic equal to 0. First thing you want to check to see if this factors. What are your factor pairs of 3? You have a 1 and 3, negative 1 and negative 3. Do either of those add to a negative 4? Certainly. Remember, we still have an equation we're dealing with here. Use your zero product property. If these are our factors, our solutions are x is equal to positive 1, x is equal to positive 3. But now students are feeling good. They got an answer. It factored. You've got integer answers. You're like, ah, man, teachers always give me integer answers, so I'm feeling good about this problem. Here's my answer. Guess what? Half off. Why? Well, remember, look at your two answers. We had a domain restriction up here. X is not allowed to be equal to 3. This solution is not valid for this problem. Okay, when you factor check all of your answers, it looks like x is equal to 1. Okay, doesn't hurt. If you have time now left over on your assessment, take that 1, plug it in. Check step. So 2 over 1 minus 3. 1 minus 3 is negative 2. Plus 1 over 1, well, 1 over 1 is 1. And that's equal to, plug this in here, negative 1 plus 1. Well, negative 1 plus 1 is 0. Okay, just make sure your denominator is not 0. 3 minus 1 is negative 2, which makes it 0. Well, guess what? 2 divided by negative 2 is negative 1 plus 1. Is that equal to 0? Yes, 0 is equal to 0. Your check steps confirming your math is good. And if you can handle this problem, you're in pretty good shape. So we have because we have a rational expression, or excuse me, a rational equation. We learned to multiply through by the common denominator, solve the problem. We had two twists with this one. One is you have a domain restriction here. You've got values of x. They're not allowed to be solutions. And you have this pattern here that you're going to see in math. And when you see this pattern with subtraction, x minus 3 and 3 minus x, use this trick in terms of switching the order and then factoring out a negative 1 to get those denominators to match. Okay, hope this helps. It's a video, so if you didn't catch everything the first time, you can watch it a couple times. We'll see you next time.